Thanks for the introduction, Carolyn. It is a pleasure to be part of the Pulsar Summit. Congratulations to you and the rest of the team for making this Europe edition to happen. In this session, I will be explaining how developers can build their own sync connectors for Apache Pulsar. This is super important if you ever find yourself in a situation where you need to send data from Pulsar to other systems, but there are no built-in connectors available for that particular system. Pulsar's implementation for connectors is called Pulsar IO. This is a framework that sits on top of Pulsar functions. All the connectors that come with Pulsar were built using this framework, and this is the same framework that I will be showing you today how to write code using Java. For those of you that don't know me, my name is Ricardo Ferreira, and I'm a developer advocate with Elastic. At Elastic, I'm part of the community team. Before I joined Elastic, I used to work for other technology vendors such as Confluent, Oracle, and Red Hat. If you ever feel the need for getting in touch to discuss anything that I'll be showing here today, whether if it's related to the talk or maybe something else such as observability, streaming systems, databases, or maybe something related to Java and Go, I have here my Twitter handle sitting at the bottom of the slide. Feel free to follow me there and start a conversation, or alternatively, you can go to my blog, and in there you will find all my contacts and how to get in touch. Like I mentioned before, in this session we're going to be talking about how can you develop your own connectors for Apache Pulsar. And for this, we're going to be leveraging Pulsar IO. In this talk, we're going to be focused strictly on the APIs and the framework itself, and not on the utilization and the operational details of the framework. If you want a crash course about this, you can scan this barcode and you'll get access to the presentation I did earlier this year on Pulsar Summit Americas. In that session, I covered in full details how the Pulsar IO framework works, the architecture of it, and all the operational details that you as a developer and a user needs to know. The approach I'm going to use for this session is providing you with a pre-existing code that I've created and made available on GitHub. So I am going to clone that repository and walk you through in the structure of this code so you can understand what classes and resources you have to create in order to build your own sync connector. Also, I'm going to discuss how can you actually extend that code to insert your own custom logic regarding connectivity or any interaction you want to do with your system that the sync connector is intended to connect. With that said, let's start by cloning the GitHub repository. All right, so the first step is start cloning these repositories. So I'm going to retrieve the URL of this repository, and I'm going to perform a local clone here on my machine. And with the code available locally, I'm going to now open this code in my IDE so we can start discussing the structure, the layout, and the API from the Pulsar IO framework. The first thing you got to understand about this code is that it is all based on Maven. So if you look at here, you're going to see the pom.xml file that already contains some of the dependencies that you're going to need to start off the development of your custom sync connector. But most importantly, you're going to see that in the plugin session, there will be this plugin called NiFi Nard Maven plugin. So as you may know, all the Pulsar connectors are based on this format, which is NiFi, and it is your job to generate this format for your connector. So what we're going to do here right now is force a first build of the code to generate here on this target folder a copy of this NiFi file, right? So basically what this command is doing, besides compiling your source code, is to actually generate this archive, which ultimately is going to act as your deployment archive. So here you have it. So now that we have a copy of the connector to work with, the other thing you got to notice about the code is that there's this Docker compose file also that provides you with a very handy copy of Pulsar server in the form of a Docker container, right? But also, you're going to notice that here there's a volume that associates this local copy of your NiFi connector to the Docker container. So what that means is that by the time we spin up this Pulsar server, you're going to be able to deploy your connector from there, which is pretty handy for testing purposes. So let's do this. We need to have a Pulsar server to work with. So let me start up the Docker container. So I'm going to run docker compose up -d, and the Pulsar server should be started. We just need to make sure that the server is healthy before we actually start using it. So it's starting up at this point. Let's wait a couple more seconds until the status of the server turns into healthy. There you have it. So it's healthy, so we're good to go. So now that we have a Pulsar server and the copy of the connector to work with, let's do a first test. That's what you're probably going to do before anything. Like you want to check the behavior of the code. So here on this folder, you're going to see that there's a script called localrun.sh. So what this script does is to use the Pulsar admin CLI with the sub-option called localrun to spin up a Java thread that will execute the code of the connector. So the connector is provided here as a parameter. Here's the NiFi archive. And along with the connector, you also have to provide a custom configuration file, which provides some parameters to the connector, as well as the Pulsar topics that will be listened because it is a sync, so it has to have some inputs. So what I'm going to do now is to actually execute this, this script here on this localrun.sh. So I'm going to enter the O2 folder, and then I am going to execute this script right now. So as I mentioned before, what this script is going to do is effectively spin up a Java thread that contains a copy of a functional copy of the connector code. So the connector is up and running right now. So I'm going to also go to the O2 folder that has another interesting script that you can use for testing purposes that sends a message to a topic, right? So I'm going to run this script over here to send one message to the topic. And what needs to happen is that there you have it. So the connector code picked up this message and processed here. So it basically prints out the contents of the message in the console. So as you can see here, the code is functional. So you can simply base your work off on this and create your own. So let me now show you some details of the actual code, because ultimately this is what you need to learn in order to build your own. So this is all Java development code, so you gotta need some basic knowledge of Java and how Java works and things like this. And if you go to the Java folder, you're gonna see that there are only two classes. I made it really simple for you to actually look to the code and then understand what's going on. So the first class you gotta understand is the actual connector code. So what is a connector? And Pulsar is a sync connector specifically, right? It is a Java class that implements a sync interface, right? So one of the interesting things that this approach allows you to is to create a very strongly typed implementation. So the type you specified here in the generic portion of here, the implementation of the interface, is going to dictate what is the actual type that you are going to handle. So right now, we are treating all the Pulsar messages as plain strings, right? So nothing fancy on this. Along with implement this interface, you also need to use this annotation, which is come from the connector API, right? And this annotation is going to specify the actual unique name of your connector, if it's a source or a sink, description for it, and you are going to provide a class that represents your configuration file. I'll talk about this in a minute, right? And you are also going to be needed to implement the callback method. So there are three that you need to implement. The first one is called open, right? So as the name implies, this method is going to be executed right after the container, the connector is instantiated in the JVM. So it is the first thing you're going to do. So it's a right place for you to establish like any connections or create resources to the target system, right? And then obviously you're going to implement this write method, which is effectively the method that's going to receive as a parameter, as you can see here, a message from Pulsar, and it is your job in this method to simply write the code that's going to write the message into the target system, right? And you have the close callback. I didn't use it here, but why and where you're going to use the close method. Maybe you've established some resources on create some threads, things that are expensive for the hardware resources consumption perspective, and you do want to close those resources to avoid any leaks in your code. So this is the perfect method to actually do this, right? All right, so not sure if you've noticed when I was describing the local run script, but I have mentioned that besides actually is providing the NAR file archive with the code of the connector as a parameter, you have to provide a configuration file. So those are going to be parameters that you're going to let your users to specify that's going to influence the behavior of your code, like how to customize your connector or things like this. So this configuration file is written in YAML, and I've created here 3 parameters, required parameter, non-required parameter, and a param with default value. So here's the question: how you actually make sure that those parameters will be read by your connector code. So what I've done here in the connector code, you're going to notice that in the open method, you have this map that is provided to you as a parameter. So this is actually all the parameters that the user specifies. So it is your job to parse those parameters. You can read them straight here from the map and then simply retrieve the values if you want. It's not very complicated. However, if you want to follow some development best practices, what you can do is actually create a Java class, a serializable one, that represent your parameters, and you're going to have all your parameters as attributes of your Java class. And you can annotate those attributes with this arroba fielddOC @fielddOC annotation. So you can specify things like, oh, this is required, this is non-required, or if there is some default value for the parameter in case the user doesn't specify them. So what I've done here is create this load method, and I've used this framework called Jackson, which now allows you to parse Java objects such as a map, and then serialize this object into the actual class that you provide here as a parameter. So that's what I've done here. I've used this class to actually load the parameters, and then I can simply reference those parameters here automatically. So let me show you something very interesting here. Like when we were testing here with the local run parameter, you've noticed that, let me execute it again so we can see it. You've noticed that when I've sent a message, the connector straight away processes the message. So it's quite fast, right? So, but there's a very important concept that you have to understand here that has to do with delivered semantics of your connector. So I am going to send a couple more messages right now. So there will be another one right here. So it's just got processed. So if I turn off the connector and execute it again using local run, you're going to notice that the connector will look like to be starting from scratch, meaning that it won't process any existing messages. Why? Because all the messages that has been processed so far has been acknowledged as process. So this is really important. So in order to make sure you understand this concept, what I'm going to do now is to comment out this record acknowledge, and I'm going to do actually another change here that's quite interesting, which is right now we are processing strings, and then if you want to handle types that are more like maybe you serialize it, your producers send messages that are in Avro or Protobuf or JSON schema, you do want to actually treat them as an object that we can reference the fields of those objects. So you can use this generic object interface here. Then you can actually start writing your code to reference all the parameters and fields and everything that declares and defines that event definition for your code. So with this new version of the code, I am going to actually perform a new build, right? Because we need to update the definition of the NiFi archive so we can see the changes in the behavior right now. So, and just to recap, this new version of the code, we are no longer acknowledging any messages that are received, and we are treating all the messages no longer as a string, right? So the new version of the NiFi archive has been generated. Good. Now we can go back to our local run script. I'm going to execute one more time the local run, and we are going to send out 2 messages for testing, right? So the code is executing. I'm going to send the first message right now. Send message, and you've noticed that no longer we are printing the contents of the message because it's no longer a string. You're going to notice that now the schema being used is bytes. Why? Well, first of all, because the CLI from Pulsar only produces bytes for testing purposes. So that's why the actual message that ended up in Pulsar is a bytes. But I'm going to send, this is not what I want you to understand. I want you to follow up the concept of delivered semantics. So I've just sent another message. As you can see here, this is the second message received, and I am going to stop the execution of the Pulsar connector with local run and execute one more time using the local run script. Now, here is what's going to happen. The connector is going to bootstrap, do its thing, but notice that it tried to process the messages, the 2 messages that I've sent before again, right? Why? Because they haven't been acknowledged. It is important for you to write code that properly acknowledge messages, because otherwise Pulsar will be treating those messages as pending and will keep sending to your connector for retrying purposes. And you know what might happen, right? If you try to retry, you might end up with duplicates in your target systems, and that affects consistency. So you have to think real carefully in terms of how you are going to handle your delivered semantics of your connector. But the connector itself is working as expected, right? So what I'm going to do now is show you how to actually deploy this connector. So you are going to notice that along with the other scripts, I've made available this one called sync create, right? In this script, it's also using the Pulsar admin CLI, as you can see here, but we're using this option create now, and instead of actually providing the NiFi archive as parameter, we're actually providing the name of the connector, right? So now we are actually referencing the connector as something that it has been deployed, and we're just telling Pulsar to execute that connector, right? So let me do this. I'm going to execute this sync create script right now, so you can see the behavior. So what this script does is to ask Pulsar to deploy that connector. So the connector has been deployed, and you can check the status of this connector. Use this other script called sync status. So as you can see here, the connector is running, but though it haven't written any messages as a sync, right? So let's do this. Let's send a couple more messages to the topic that this connector is listening. So that was the first message, and then I'm gonna send another message, right? So now the connector has conceptually processed 2 messages. If we execute the sync status script one more time, what it needs to happen is that this matrix here needs to be updated. Here we go. So now the connector has processed 2 messages, as you can see here. So feel free to play with the code. It's available on GitHub, and I think that will give you a very good jump start in your journey to create your own sync connector. I hope you have enjoyed this presentation and learned how to develop your own custom sync connector. If you want to do a recap in everything that has been shown here today, you can scan this barcode where you will have access to this, not only this presentation, but also the recording of it. So feel free to use this as your learning resource. With that said, I would like to thank for your time, and I hope that you enjoyed the remaining of this conference. See you next time.